Alright guys, so the first thing I'm going to do is I'm going to start off with a little bit of a review of some stuff that we've been doing before we went on this little break, if we want to call it that. And so I've got a little bit of review questions here. You may want to pause the video here and try it first to see if you can do it right, and then unpause and watch the video. Push play. So on this one it says use 4x plus 9y equals 18 for the following problems. And there's a couple problems. We're going to do 4 problems. It says rewrite the equation in slope-intercept form. That is that y equals mx plus b. Remember, the reason it's called slope-intercept form is because the slope is m and the y-intercept is b. So that's why it's called slope-intercept form. So to rewrite this equation into slope-intercept form, what we need to realize, first of all, is that Mr. Harrison is giving us the equation. All we have to do is rewrite it to look like this, to be y equals mx plus b. Essentially, what that means is we are solving for y. We're getting y by itself. So, how do I get y by itself here? The first thing I need to get rid of is the 4x. So I'm going to subtract 4x because it's a positive 4x. And what I do to one side, I've got to do to the other. So I subtract 4x on the other side. We've talked about that a lot this year. Make sure what you do to one side, you do to the other. Now the reason I subtracted 4x, like I said, is because now it's going to cancel that out, 4x minus 4x, and it's going to leave me 9y. 18 minus 4x is just 18 minus 4x. You can't really subtract those. 9y is still not completely isolated the y though. So now we need to get rid of the 9. So what do we do if you have 9 times y? The opposite of multiplication is we divide by 9. And what you do to one side, you got to do to the other. Just like we talked about just a minute ago, I divide by 9 on both sides. So when I do 9 divided by 9, that cancels out to just 1y. Be careful there. That doesn't cancel out to 0. Please be careful. Then we divide both of these. 18 divided by 9 is 2. You can use a calculator if you need to. And just as a quick reminder here, I know some of you don't have a calculator like I have. You can always go and check on desmos.com if you would like, desmos.com, and hit start graphing. And although this is typically used for a graphing calculator, you can also do simple things like we just did, where we had 18 divided by 9. You can do 18 divided by 9 and get 2. So you can still use that to divide things if you need to. Negative 4 divided by 9 is negative 4 ninths. Remember, the reason I'm leaving that as a fraction is because that is my slope. Now, some of you may look at that and think, no, it's not. But remember, this is not technically in slope-intercept form yet until I switch it around to be negative 4 ninths x plus 2. And I switch these two technically to put it into the true slope-intercept form. It's mx plus b. mx plus b. So my slope is negative 4 ninths. My y-intercept is 2. Now, we'll come back to that here in just a little bit, because remember, there's a very quick way I showed you how to use this to graph an equation. Number 2 asks us to find the x-intercept and the y-intercept. So we can start off with that same equation we started off with a minute ago and find the x-intercept and the y-intercept for that equation. Again, you may want to pause the video here and try it first. That way to see if you're actually getting it right on your own. Now the answer, if I want to find the x-intercept, remember the x-intercept is on the x-axis. And so on the x-axis, any point on the x-axis, the y value is going to be 0. So if I want to find the x-intercept, I plug in 0 for y. Notice that is not the same thing that I was doing a minute ago when I solved for y. This is not even close. The x-intercept is only one point on the line. It's not the whole line. So we plug in 0 for y. So we do 4x plus 9 times 0 equals 18. 9 times 0 is 0, so that's just going to be 4x equals 18. We divide by 4, and you get x is equal to 18 divided by 4, which is 9 over 2, or 4.5 as a decimal. The decimal may help you a little bit better when you think about this as a point on the graph. It may help you graph a little better. Remember, I also told you this is where I'm going to be a jerk math teacher, and I'm going to require you to write your answer as a point, as a ordered pair. So if you write your x value, 4.5, and your y value you plugged in was 0, that is the x-intercept. Like I said, that would be a specific point on the x-axis. The y-intercept is basically the same concept. The only difference here is now we're talking about points that are on the y-axis. Anytime you are on the y-axis, any point on the y-axis, the x value is 0. So if I plug in 0 for x, that is going to find the y-intercept. Notice that is not the same thing that I did over here when I got y by itself to slope-intercept form. Please know the difference. So this is going to be 4 times 0 plus 9y equals 18. So you just plug in 0 for x. This cancels out, leaves me with 9y equals 18. Notice that is not the same thing, like I said, as solving for y. This is just finding one point, the y-intercept. Yes, this should be, at this point, the same concept we did a minute ago. We're going to divide by 9. But we're not finding the line, we're finding 1 point. 18 divided by 9 is 2. That means my y-intercept has an x value of 0, that's what I plugged in, and a y value of 2, that's what I got. Remember, these are two separate points on the graph. If you just kind of approximate where those are, and we're going to talk about that here in just a second in a little bit more detail. 4.50 would be over here, 0.2 would be over here. Now you have two separate points on this line. And you could connect the dots if you wanted to make the line. And we will come back to that here in just a few. Number 3 says find the slope. Well, what do you need to find the slope? Well, slope formula is y2 minus y1 over x2 minus x1, or rise over run, right? The problem is the only points that I have are not exactly really pretty, 4.5 and 0 and 0.2. So I'm probably going to have to use the formula. So again, pause the video here and see if you can find the slope between those 2 points using your formula. So here's how you do it. y2 minus y1 over x2 minus x1. If you need to, you can always label your points here. You can say, okay, that's x1 and y1. That's x2 and y2, because this is the x and y from the first point, x and y from the second point. Then we do the math here. 2 minus 0 is 2. 0 minus 4.5 would be a negative 4.5. And we can use our calculator to help us here. 2 divided by negative 4.5 is going to give me negative 0.44444. Math, enter, enter. And guys, like I said, you can use the Desmos calculator if you need to. Negative 4 over 9. So my slope is negative 4 over 9. Let's go back over here for just a second. What did we figure out our slope was in the very first problem? If you look right here, our slope was negative 4 over 9. So when we get the slope of negative 4 over 9 here, we've got a way to check ourselves. That slope is exactly the same no matter which way you find it. The last question says graph the line. For sake of time on this review, I'm not going to go through the long process, but the long process that I'm talking about is you could take the slope intercept form, negative 4/9 x plus 2, and you can make a table of values, plug in some numbers for x, plug those in for x, and get your y values right here. That's an option. I'm going to use our quicker methods. One of those methods we learned was to take the x-intercept, 4.5 and 0, take the y-intercept, 0, 2, and graph them. So you can try that real quick. Graph your line. You should have a point at 0, 2, right here up to my y-intercept, 4.50, right here, my x-intercept. Notice again the x-intercept's on the x-axis, the y-intercept is on the y-axis. And then you could connect those dots and make your line. Now, I'm not going to draw my line yet because I want to talk about the other quick way of graphing. The other quick way of graphing was just to look at your slope and look at your y-intercept from that slope-intercept form you talked about previously in the chapter before. Y equals mx plus b. Remember I told you can begin your graph at 2 and then move to the next point using their slope. I know it's a goofy way to remember it, but you begin at 2. So if you go up 2, there's my point. Oh, look, it's the same point. Imagine that. And then I move down 4 over 9. I go down 4, 1, 2, 3, 4, over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Rise over run. You still notice, if you look closely, that line is still the same line that we started with, even with our x-intercept and our y-intercept. It doesn't matter which method you use for graphing, you're still going to get the same points. Okay? So I know these graphs on here are not perfect, but that's the same line. And if you plotted these points, if you made a table of values, guess what? It would be all the same line. So this is the stuff that we've been doing for the past, oh goodness, probably 6 weeks now. We dealt with slope and the y-intercept and the x-intercept and graphing lines and what lines should look like on the graph and whether they go up or down. If it has a negative slope, it goes down. Positive slope, it goes up. This line's going down. So we did a lot of stuff with linear equations. So in this new chapter that we're about to start here, I know it kind of sucks. You're at home by yourself, but I'm going to be doing these lessons just as if I was teaching you in class. You can pause the videos. You can rewind the videos. You can go back and watch it 30 times if you want to. If you need some extra help, I'll be on WebEx. Over the next couple of days, I'll set up some times for you to get on WebEx and get some extra help if you need to. But you can go through and look at these lessons just like Mr. Harrison was teaching it to you in class. Obviously, it would be my suggestion that you stay awake. Right, Avery? It'd be my suggestion that you stay awake and try to actually do the lessons and not get behind. So, what we're going to be looking at is still looking at linear equations, still looking at this y equals mx plus b format, still looking at this format that's just actually called the standard form of a linear equation, and writing equations in those formats. So, if you would like to title notes that you want to take some notes with, and by the way, that'll be helpful because when we have quizzes and tests and things, you'll be able to use your notes when you're at home. Writing linear equations in slope-intercept form, that's basically what this chapter is going to be about. So today we're going to be looking at specifically slope-intercept form, meaning we're going to focus in on times when we have the slope and we have the intercept given to us in the problem. Like I said, anytime you need to pause the video, please pause it. I'm not going to go slow and pause too much in the video itself. I'll do that when we do some live stuff. So you don't need to write this down here. But in this lesson, what we're going to learn is to write an equation of a line. So this is going to be the big key here. Write an equation of the line. So we're not just graphing the lines anymore. We're actually also writing the equations using the slope and the y-intercept. So what we need to do is we need to have the slope-intercept form of the equation and plug in the slope, plug in the intercept that we are given in the problem. So you may want to write this little part down right here. In the equation, the m is the slope and the b is the y-intercept. Remember that the y-intercept is the y-coordinate of the point where the line crosses the y-axis. So when I say y equals mx plus b, I'll say it again, we did this earlier, but the m is the slope and the b is the y-intercept. And so what we're going to do is use those numbers to create our equation when we are given those. And we're going to do some real world examples too. It may not tie directly to your life, but we'll look at that a little bit here in just a second. So again, pause the video if you need to copy some stuff down. First problem. This is what it's going to look like when you do one of these problems on a quiz or a test for me. It's going to say write an equation of the line whose slope m is -2 and whose y-intercept b is 5. Now this one is very, very explicit in what it tells you to do. It's very, straightforward. It says the slope m is -2. Y-intercept b is 5. So if we know that we're looking at the slope and the y-intercept, y equals mx plus b is the way the equation is supposed to look, all we have to do is use the slope and the y-intercept that's given to us to write the equation. So you may want to pause the video here, try it real quick, see if you can get it. Now that you've tried it, y equals mx plus b. What's m? -2. So -2x plus b is 5 plus b, so plus 5. There's my equation of my line. There's something I could graph. There's something I could make a table of values if I wanted to plug in some numbers. Or maybe you can just plug in one number and get an answer. That's going to be more likely in your real life type situations. And we'll talk about that in just a little bit. So if you have the m and you have the b given to you, all you have to do is plug them into the right spots. So try this one real quick. So the slope is -2/3. The y-intercept is -4. So that would be y equals -2/3 x minus 4. Now, why did I put -4 instead of plus negative? It doesn't really matter, but typically instead of writing plus -4, we write minus just to save us some time and to save this double negative sign from confusing some people. So instead of writing plus -4, you'll see me write -4. It's still -4 though. If you were to cover that up, you could see that that is still -4. So my slope was -2/3. My y-intercept was -4. Now again, think about what that means graphically. I'm not going to make you graph all of these or anything, but think about what that means graphically. That means -4 or down 4 spaces is my beginning point, my y-intercept there. My slope is -2/3, so my slope I would go down 2 and then over 3. So I would go down 1, 2, over 1, 2, 3. That would be where my next point is. And then I could connect my dots and make my line. So that's what this line is. So anytime you know the slope and you know the y-intercept, you know the equation. And so that's what you're going to be looking for. That's what you're going to have to do on quizzes and your test. Okay? So here's another one. Now to make headaches a little bit easier, let's say it passes that point right there and that point right there. Well, Mr. Harrison, you didn't give us the slope and you didn't give us the y-intercept. I imagine that's what some of you might be saying, right? Yes, I know you're not saying it like that, right? But you are given the slope and you are given the y-intercept. You just actually have to do a little bit of counting to figure out what they are. Notice this point right here is the y-intercept. If you go down 4 spaces, the y-intercept is at 0, -4. So my b value is -4. You were also given the slope. I know it's not as easy to see, but the slope is given to you as well because it goes up 2 spaces and over 1. That is rise over run, up 2 over 1. So my slope is 2. Now, if you leave it as 2 over 1, I'm not going to be mad at you, but it is, like I said again, a way to save yourself a little bit of space when you write your equation, but also to realize that that is what 2 divided by 1 really is. 2 divided by 1 is a whole number. So my slope is 2. My y-intercept is -4, so mx plus b. Now again, notice it's -4, so that's why we put -4. So whenever you have the m and the b given to you in the problem, all you have to do is be able to use that y equals mx plus b and plug in the m, plug in the b, and get your answer. All right, here's another one to try on your own, and we'll again try to make it a little simpler here because this graph is a little bit off. We'll say it crosses there, and we'll say it crosses there. So pause the video here and see if you can find the slope-intercept form. So my slope, it's going down 3 over 1. So my slope is -3 over 1, or just -3. My y-intercept is right here. My y-intercept is at 0, 3, or my b value is 3. So my equation would be y equals -3x plus 3. So that is the equation of that line. So now what we're going to transition into is, okay, well, how does this happen in real life? How does this model a real life? And so sometimes you'll hear people talk about a linear model. That's a linear function that's used to model real life. Okay, so don't get look at that and read that the wrong way and think a linear model is somebody who's just a really really skinny runway model. Some of you will get that joke later. But a linear model is how something that's a linear equation models or describes mathematically what is happening in real life. Well, we've already talked about this with the slope a little bit. The slope is the rate of change in real life. So when something's changing by the same amount over and over and over and over again, that's called the slope. The b is the one that we hadn't really talked about, but I've given you a little hint. It's the initial amount. Well, that doesn't sound familiar to me, Mr. Harrison. I'll think about it this way. Remember when I did y equals mx plus b, and I said that this is the beginning point, and this is what you move with? Guys, that's what this means. B is the initial amount. That means that's the beginning amount. That's what you start with, the beginning point. The m being the rate of change is how much it is moving, how quickly it is moving. So if you have things in real life that have a starting amount and they change by the same amount over and over again, you have an m and you have a b. So what we do in a real life context is we just use that to help us make predictions and make approximations. If you guys remember the question that I gave you about the coronavirus, there are scientists and doctors that are making predictions about how it's changing. But if you'll notice, a lot of you found this out, is that the change in the coronavirus is not linear. It's not changing by the same amount every day. So that's why that one is creating a graph that actually looks kind of like this if you've seen it on the news. It's curving. Linear is a straight line. So we're talking about things that are linear. They have a beginning amount that's a starting amount, a beginning amount, and a constant rate of change the whole time. So we'll look at a couple examples of that. Example number 1. And again, you may want to pause the video and see if you can kind of wade through it and try it on your own first. And then we'll do it together as well. It says linear functions can approximate population change. And those of you who found out that population can also be approximated by that exponential function you saw about and read about, would realize, hopefully, that that's usually the thing we use for population. But linear functions can be used to approximate it. So notice part A here says, write a linear equation to approximate the expected population of California in any year between 1990 and 2005. Use the following information. So here's the key. We're writing a linear equation. So we're trying to do y equals mx plus b again. We need our slope and our y-intercept, right? But in real life, those things are not going to be called the slope and the y-intercept all the time. Like I said, the b is going to be your beginning amount. The m is going to be the rate of change, how quickly it's moving. So look at the problem. It says, use the following information. In 1990, California had a population of about 29.76 million. What is that number? I'm hoping you're screaming at the screen that right there, 29.76, is the beginning amount. That's the B. How do I know that is the B, 29.76 million? Well, because it says in 1990. You're looking at years between 1990 and 2005. That's the beginning year. That's the beginning year. That's the beginning amount. If that's what you're starting at in 1990, that's the beginning amount. Now, is that the beginning population of California ever? All time? No. This is talking about this one little situation we're talking about from 1990 to 2005. So then the next part of the problem says, during the next 15 years, the state's population was expected to increase by an average of about 0.31 million people per year. What is that? Again, I hope you're screaming at the screen. That is my M. That is my slope. How do I know that, though? Mr. Harrison, that don't make sense. That's not rise over run. Actually, look at it again. It's increasing, so that means it's positive, and it's millions of people per year. Guys, when we talk about rise over run in a real life situation, we're talking about things like that. It's people, in this case, millions of people per year. So it's going up 0.31 million people each year. That is my slope. So now what we can do, just like we did on the previous problems over here, where we had the M and the B, 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 we know the slope, we know the y-intercept, so we can find the equation of the line is y equals 0.31x plus 29.76. My M and my B. You could also use P for population, 0.31 T for time or years, plus 29.76. I'm just using y equals mx plus b to keep things familiar for us, but you can use different variables. It doesn't matter. Also, I want you to realize that some of you can come up with this equation right here without really thinking M and B. If you just think about logically what you would do. If there's 3.31 million people per year, you would multiply that by the number of years and add that to the original amount of 29.76. Guys, that is what this means. mx plus b is not something fancy. It's just putting into a format that you guys can use over and over and over again the fact that you know the beginning amount and you know what it's changing by or moving by. So now we're going to do part B. And part B is really where you get into the whole point of doing this math in the first place. Part B is where we use the equation. Okay? Now, some of you are going to say, well, then I don't need the equation. I can do part B without the equation. Well, technically, no, you can't. You're using the equation. You just didn't write it down on your paper. Because no matter what, you're going to have to use this equation in the calculator if you want to find the answer to part B. Let me show you what I mean. So, part B says, use the equation to predict the population of California in 2005. Well, 1990 was 29.76. It's growing 0.31 million people per year, so we got this equation. What do we do? Well, 1990 was the beginning. 2005 is 15 years later. And so 15 years is what I actually am going to plug in to my equation. 0.31 million people per year, so times 15 years, plus the 29.76 million we started with. Guys, this is what you would do in your calculator anyways, even if you didn't write the equation. So you can't tell me you wouldn't use the equation. You're just telling me you wouldn't write it down. And I get that. In a real life situation, you may not sit and pull out your paper and your pencil and your calculator and be a nerd in front of everybody, but you're going to use it if you're trying to predict this population. So you take out your calculator and you do 0.31 million people per year for 15 years plus 29.76. Add those together and you get 34.41, be careful here, million people. It's not just people, it's millions of people. If it was just talking about people, not millions, you would not be able to use this decimal here because you can't have 0.41 of a person. I don't care how short they are, they're still a whole person, even Mr. Woods. Okay? So when you're looking at 0.41 million people, you need to realize that that is okay to leave that decimal. But when you're looking at just people, that's not okay. All right, let's try it again. Use the table below here to see if you can figure out the linear equation. And I'm sorry for the little gaps here in this writing. I don't know why I did that. Okay, so now hopefully you've paused it and you've tried it. It says you can approximate collect telephone call charges using a linear function. Now, I know some of you don't know what that is, but it's okay. You don't really need to know what that is. Basically, it's a way to call people and let them pick up the cost of the phone call. It's kind of what people do, and I hate to say it this way, but sort of what people do in prison when they make their phone call from prison. The person who is receiving the call picks up the charges. So it says use the information in the telephone bill to create your linear equation, to create your linear model. So notice, do you have a beginning amount? Do you have a m, what it's changing by? If you pay attention to the table, I hope you can see it. If you look right here, the first minute, that's my beginning amount. That's my y-intercept. How do I know that's my y-intercept? Because it says the first minute. Guys, you got to pay $3.44 no matter what. You don't get an option. If you make a 1 second phone call, you got to pay that. So that is my beginning amount I got to pay. Then if you look right beside it, there's another key little word here. It says the rate. Remember what I told you about M? I said it's the rate of change. The slope is how quickly the line is changing, how quickly it's moving. This 24 cents, be careful here, there is a little understood thing you got to know, per minute. Now, so it's $3.44 for the first minute, and then 24 cents a minute after that. And that was the key thing that you might have missed if you tried this one on your own, is the after that portion. Let me show you what I mean. The equation would be y equals mx plus b, so it'd be 0.24x plus the beginning amount, 3.44. Now, probably somebody out there is thinking, well, Mr. Harrison, can I do the 3.44 first and then the 0.24x? Because like you do on a real phone call, you do the 3.44 first, pay for that first minute, then 24 cents a minute. That's fine. That's okay. If you want to do it that way, that doesn't bother me. I'm just writing it in that format, again, to kind of keep things consistent for you. Mx plus b. So, here's the tricky part. It's really part B here. It says, part B, how much would a 9-minute collect telephone call cost? Okay, so this is part A, part B. Now, before you get all excited and say, oh, you gave us the answer right there. 9 minutes is $5.60. You're wrong. What do I mean? You're wrong. That's a 9-minute phone call, Mr. Harrison. No, 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 no. Pay attention right here. What does the wording say? That's the additional minutes. Pay attention right here. You pay $3.44 for the first minute, no matter what. The 24 cents a minute is after you've paid for the first minute. So really, to do part B, you actually have to plug in for a 9-minute telephone call. You plug in 8. not 9, because $3.44 is what the first minute already costs. 8 minutes or 24 cents each minute. So then we go to our calculator, though. Now it's just calculator work. 0.24 times 8 minutes. Remember, 24 cents per minute plus my $3.44 for the first minute. Press enter, and it's $5.36. Again, it's okay for me to use decimals there because we're talking about money. So pay attention to what the problem's talking about, and pay attention to what the B and the M really mean. The B is the beginning amount, what you pay first. Then it's the other stuff on top of that. So a 9-minute phone call is really 8 additional minutes. So be careful with that. And that's important to understand in a life situation. It doesn't just have to be collect telephone calls. There's other things in life that have a price you pay up front and then a price per visit. For instance, if you were a member somewhere at some type of, I don't know, let's say something like, like a rock climbing gym or something. We did an example with that earlier this school year, I believe. And you paid a membership fee, and then you had to pay like $10 a visit. It's going to look exactly like this kind of setup. All right, here's another one for you to try. Think about this and be like going on the doodle trail or something, and you're going to rent a bike. It says, suppose that bike rentals cost $4 plus $1.50 per hour. All right, so see if you can write your equation. Don't do part B here. Then use the equation to find the cost of renting a bike for 12 hours. We're going to look at a slightly different question on this one too after you try it. So pause it and try it. So part A here says write the equation. So my M and my B is what I'm looking for. I'm looking for that y equals mx plus b. M is $1.50 per hour. My price is going up $1.50 every hour I use the bike. My beginning amount is $4. No matter what, just to rent the bike, it costs me $4. Even if I only ride it for half an hour, 10 minutes, it costs me $4 to rent the bike. So my equation, would be y equals 1.50x plus 4, or $1.50 each hour plus the original cost of 4. Part C, since we skipped over B, use the equation to find the cost of renting a bike for 12 hours. So again, $1.50 per hour, so $1.50 for 12 plus 4. Notice this one is different than the example with the telephone call because the $4 doesn't get you any time. That just gets you the bike. The $1.50 is how much I pay for each hour. So $1.50 times 12 plus 4. So I take out my handy dandy calculator. I do $1.50 times 12 hours plus 4. Oh, goodness. Love the calculator. Technology's been really liking me the past few days. $22. So it cost me $22 to rent it for 12 hours. It's not bad for renting a bike, but that's how much I would need to have in my wallet if I'm going to rent this bike for that long. So let's look at it from another perspective here. I'm going to kind of change things up. It's not on the screen right here, right now. So let's say that we know we have, let's say we got $10 in our pocket. That's all we got. We don't have any more money, but we want to hang out with our friends and they want to ride the doodle trail because there's nothing else we can do when we're cooped up with quarantine, right? So we want to go do something. So we want to get out on the doodle trail and ride the bike, but we only got $10. How many hours can I ride? So how would I figure that out? Well, $10 is not X. You can't plug in X. Remember, X was the number of hours. Y is the total cost. So we actually want to plug in 10 for Y and then solve this equation for X. So take a minute, see if you can get x by itself. If you subtract 4, that's your first option, you get 6. Then you have $1.50 times x is 6. And what that's basically doing, if you think about real world, it's subtracting off the $4 you got to pay to rent the bike. Now you're going to figure out how many hours you can actually rent it by dividing by 1.50 or dividing by $1.50 into 6. So you get x is equal to, take out your handy dandy calculator, do 6 divided by 1.5, and you'll get 4. That's the number of hours that I can actually rent the bike. Now, depending on how fast you ride the bike, that would limit where you can go. Can you ride all the way to Easley, get some to-go lunch at Morel's and eat out on the patio or something? Nope, probably not, unless you're pretty fast on the bike. It takes a pretty good while to ride from Pickens to Easley on the Doodle Trail. So this is the type of decisions that you'll actually have to make in a real life context. You may actually have to make these types of decisions one day in your life. Now, that depends on how much money you have too, obviously, but you can make those types of decisions and it helps you be smarter with your money. All right, so that is our lesson for today. The only thing I want to add on here, because there's a few review problems on your homework, make sure you go back and you look at how to find the slope, y2 minus y1, x2 minus x1. And then make sure you also go back and look at direct variation. You may have to look that one up. We did that one in the last chapter. That's when you have y equals kx, or another way to write that is y equals mx, but it doesn't have a b value. That's when we have those real life situations that just have the slope. They didn't have a b value. Think about that would be something like where you're working a job and you have a minimum wage job. You're making, $7.50 an hour? And then you work 0 hours? You're going to make $0. So you would not have a beginning amount. If you don't work, you don't get the money. Now, I know we got some weird stuff coming from our government for unemployment, but hey, it is what it is. But that's what direct variation is. So you'll have a few of those review problems. If you have any questions about those, I can definitely go through those on a WebEx live meeting with you. All right, so that's our lesson. Last thing I want to show you is, and I don't have it posted just yet, but it'll be posted on here soon, is when you go to Schoology. Okay, we'll see if Schoology is working for me right now. Sometimes it's been in and out over the past few days. When you click on your courses and you click on Foundations in Algebra, I will create a folder on this Foundations in Algebra thing that has down here, just like I created for the Math in the Real World project. I'll create a folder down here that has our lesson for today, has the video, and has the homework on PDF. I'll probably put a Word document too, just in case anybody else can open that. But I will create a little folder just like I did for this one, and you'll have a place where you can click and find your assignment. Then, when you click on it, you will be able to submit it to me. It'll be very similar to what some of you did when you clicked on the Math in the Real World project and you came to that. I don't have the same thing that you guys have here, but you'll be able to click over here and do your submission. You can take a picture of your homework and you can send it to me through there, or you can write down your answers, type in your answers into a Google document. I do not care. Just realize that if you decide to try to utilize things like PhotoMath, or you try to utilize Google, like some of you did on your project, and you try to use your friends maybe even, like some of you did on your project, you'll know who you are when you see your grades, then you're going to not know how to do this and you're going to fail. So you need to make sure that you actually go learn the stuff. All right, so we'll set up some times for WebEx if you guys have any questions. Guys, I hope you're doing well. Truly, I know you may not believe me when I say this, but I love you guys and I hope you guys are doing okay.